Dr. Dhawas sir, good afternoon.
Hello, good afternoon, sir. Am I audible?
Yes, sir, you are audible.
Thank you, sir.
Sushil sir joined or not?
Yeah, Sushil sir has joined.
Okay.
Sushil sir, are you there?
Yes, Dhawas sir, I'm there.
Yeah.
So I think we'll wait for 2-3 minutes. So then we'll start.
Okay.
Some participants will join within 2-3 minutes. So we'll start.
One minute.
No, sir, can we start? No?
Yes, sir.
Yes.
Yes, am I audible, sir?
Yes, you are audible. I will start, then you can introduce to our speaker.
Okay, sir. No problem.
So good afternoon to all the participants. Now we are in the last day of our 6-day online ATAL FDP. So today, as usual, I already posted the message. We are having 3 sessions this last day. So first session from 2 to 3:30 p.m. Then second session from 3:30 to 5 p.m. and third session from 5 to 6:30 p.m. And after 6:30 to 7, we are having the validity session. And in between, if possible, then we will conduct the test. We are trying for test for today itself only. But if any problem or issue, then we will convey the message today only. So we are trying for conducting the test on same day. So it will be helpful for us. So we are moving ahead for our today's first session, 2 to 3:30. So I request to Dr. Nitin Dawas, sir, please introduce our today's first speaker.
Thank you so much, Dr. Satish More, sir. Good afternoon, everyone. On behalf of organizing team of this 6 days ATAL FDP on emerging trends in renewable energy, climate change, and mitigation, I, Dr. Nitin Dawas, coordinator for this FDP, would like to introduce our today's speaker, Mr. Sushil Bagal. He is an accomplished senior test automation engineer and an expert in software development engineering in test, also bringing with him 10 plus years of rich industry experience in manual and automation testing across diverse domains, including banking, finance, media, and cryptocurrency technologies. Sushil has deep expertise in STLC, SDLC, and agile methodologies with a strong command over the complete testing life cycle, from requirement analysis and test planning to the execution, defect tracking, reporting, and CI/CD based automation. He has worked extensively with leading test management tools such as Jira, Azure DevOps, and TestLink. His technical proficiency spans a wide range of tools and technologies, including automation tools, programming, frameworks, DevOps, and CI/CD, and databases like SQL Server, and his specialized expertise in cryptocurrency systems, banking applications, API automation, TestNG, and Maven. Currently, Mr. Sushil Bagal is associated with Zorient as a senior test automation engineer, where he leads end-to-end API automation for MasterCard's crypto transfer solutions. His work involves rigorous validation of P2P crypto transactions, ensuring reliability, security, and performance, contributing directly to the next generation transactional platforms. Prior to this, he served as senior analyst at Synchron Technologies, playing a key role in manual and automation testing of APIs for global banking clients. He is also responsible for regression, sanity testing, production validation, framework development, and providing testing sign-offs for critical deployments. He also brings experience from the e-commerce and retail domain, having worked with UA brands, where he contributed to the master product management, catalog integration, ETL processing, pricing systems, and B2B customer integrations. His expertise includes business rule analysis, SQL-based operations, and managing integrations with Microsoft AX 2012. Throughout his career, Mr. Bagal has worked on several high-impact projects, including crypto solution, HSBC Midas, AX integration, E-on-Track, that is solution for mental health facilities, and handling patient life cycle workflows. Mr. Bagal holds the MTech degree from Sinhagad Institute of Technology, Pune, and the BTech degree in engineering in computer from Nagpur University. He is known for his analytical mindset, strong problem-solving skills, and hands-on expertise in automation. He continues to contribute significantly to the evolving landscape of software testing, automation frameworks, and API quality engineering. So we are honored to have him as today's speaker for this ATAL FDP. So I request everyone, all the participants, to join with me in warmly welcoming Mr. Sushil Bagal, today's resource person for this faculty development program. So I welcome Sushil sir and hand over to the Sushil sir. Welcome, sir.
Thank you very much, Dr. Dhawat sir. And
Thank
thank
you, sir.
you so much for such an extensive and nice introduction. And I would also like to take this opportunity to express my gratitude to Nutan Maharashtra Institute for conducting this session and giving me this opportunity to be part of such a program where such a distinguished engineering faculties who are doctorate, postdoctorate, they have joined, and it is really thought-provoking, and I'm really happy to be part of it. Uh, Let me share my screen and just a minute. Sorry for the delay. Are you able to see my screen?
Yes, sir. Yes, sir.
Okay. So this is the
Sir,
agenda.
your screen presentation is not visible right now.
Okay, just give me a moment.
Your screen is visible.
Okay, just a minute. Is it visible now, sir?
Yes, sir.
Okay.
Yes, visible, sir.
Okay, thank you very much. So today's agenda of the discussion is understanding the different IoT devices which are present in the market. That is not the in-depth session, but it is a high-level helicopter view where we get to know the entire ecosystem of IoTs from hardware till software. What are all subcomponent and building blocks of these IoT system, that is sensors, devices, how we connect to it, and what are the actuators, what are the different cloud systems which are able to help in this IoT data capturing and processing and its analysis. And we will also touch upon the latest AI trends and how they are facilitating this IoT things and giving edge over the classical IoTs. We will also discuss the market growth, since last few years, how these IoT system have performed, and in future also how they are expected to perform. We will see a couple of real world use cases where these IoT systems are used. Latest trends, as I already explained, AIoT, that is artificial intelligence enabled IoTs, and what are the challenges we have in this IoT system, and how we are seeing the future shaping for these IoT system in the future, that we will see. In addition to that, we will also discuss about the cost of each and every building block of IoT ecosystem as a whole, how much hardware cost and how much software cost, what is the ROI, why we are not seeing that much growth as the software industry alone has shown, and what are the challenges and why these IoT project generally fails. Those kind of scenario we will see. In addition to that, since it is a faculty development program, we will also see how the engineering student can be trained to have at least basic knowledge, entry level knowledge, where they have leverage over the other institute students, so that they can know little bit more than other students, and what roadmap they should follow in order to be part of this IoT engineering field. And at the end, we will see different IoT applications in detail, and that completes the today's agenda. Now, moving on to the what is IoT really means. So, if everyday normal devices, they are equipped with internet, data processing, and some actions using automations, then that specific device become our internet enabled device, or we also known as Internet of Things. So it is a network of connected physical devices with sensors which sends and receives the data. Okay. It enables automation, remote control, and monitoring. For example, a simple fan in our house that standalone cannot be considered as an IoT device. But what if that fan can sense the temperature in our room, and that temperature data it can send over the wireless communication system to some centralized system, be it cloud or non-cloud, and there certain decisions are made, and those decisions then converted to the action, like increasing the speed of fan or decreasing the speed of fan. In that way, that particular fan becomes a smart fan or IoT enabled device. So what is the basic building block of any IoT system? So any IoT system consists of devices, connectivity, cloud, application, and AI. That is optional part. But now since it's a trend, then some AIoTs are also there. So basic job of sensors, we all know that temperature, moisture, pressure, noise sensor, different kind of sensors are there. So these sensors collect the data and send to our controller system. What are those controller system? We will see in future. But the basic job of sensor is sensing. Now actuators are actually performing the actions. We know that in terms of AI is like a brain. Whatever you ask them, it will give you a reply back. But when we talk in terms of agents are like hands and feet. They perform actual actions. In similar way, actuators are things which perform the actual operations, be it motor, relays, or robotic arms. These are some examples of actuators. Now these devices send this data on connect wireless communication network, that can be Wi-Fi or Bluetooth low energy devices, LoRaWAN, or even 5G. Now the data goes to some centralized system where the data is stored, the data is processed, and certain decisions are made based on the input data. So we have different cloud hosts that host this particular data. We will see that in upcoming slides. An application, we need certain user interface applications to control all these things. So we can use our regular mobile phone tabs or even we can create our custom dashboards where we can see all these data. And with the AI, these smart devices become more smarter, and they can be self-operated, self-healed. They can make more decisions based on the data they have collected. Now, how this IoT works is, we just saw in last slide, there is a sensing layer. So if you see the leftmost diagram, there are sensors at the bottom. So these are different sensors which sense the data, and they send these data to the wireless communication through the gateway to our processing unit, which can be hosted on different cloud platform. And now this specific uh, processing unit then analyze the data, make some decision, and convey the decision to our application. And on the basis of application, we can either turn on or turn off, or even this process can be automated also without any human intervention. So just we saw in the last slide, there are sensors, actuator, communication layer is Wi-Fi, LoRaWAN, Zigbee. Networks are used for the transmitting the data, uh, where different routers or switches can be used. And there is a cloud layer where storage and analytics happen. And on the application, we can see the result of those analysis, or even with the touch of our finger, we can operate or perform certain actions also. So now moving to the next part, sensors and actuator. So commonly used sensors are temperature sensor, humidity sensor, motion sensor or infrared sensor, gas or smoke sensor, light sensor, pressure sensor, sound sensor. Apart from that, there are vast range of other sensors also. Ultrasonic sensors are there, and pressure sensors are also there. And there are different tags also available. For example, NFC, and but they perform in different way. Uh, Similarly, there are actuators. If you can see motors, valves, relays, or robotic arms, they perform the actual action based on the data sensed by our sensors. So these are example of sensors and actuators. Moving to the next slide, where we will see connectivity technology. Now, whatever data our sensors have collected, that data need to be transmitted. And for the transmission purpose, different wireless communication technologies are used, such as Wi-Fi, Bluetooth, BLE, and Zigbee, LoRaWAN, 5G, IoT. Now, based on two things, certain communication or connectivity system is considered. What is the data rate at which you want to operate, or for what range you want to operate? So all these systems have different range and different data transfer capabilities. LoRaWAN generally used for large area networks, maybe till 15 kilometer. We can operate using the LoRaWAN. And similarly, other these Wi-Fi and 5G and Zigbee, they have different kind of ranges and data capability. If you see the diagram at the left, you can see uh, where they stand in terms of range and in terms of the data rate at which they operate. If we see Wi-Fi, they are used for high bandwidth, but range is comparatively low. But in case of Bluetooth, it is a low power device and required very minimum power, and generally used for phone connectivity. Similarly, Zigbee operate on mesh network, where in between the two device which wants to communicate, there is another device. So that device, through that device, communication can happen without using a large amount of power. LoRaWAN is generally for cities where the range is high, and that also requires the low power. 5G is extremely fast, and their latency is very low. So that generally are used for robotics and vehicles. Our next slide is about cloud platforms. So generally, whatever data sensor senses, and that data is transmitted through wireless communication and sent to one centralized system that can be a cloud system. So what are the different cloud host platform available? That is AWS IoT is available, Azure platform is also available, Google is available, and Thingsboard is an open source system that does not charge you any hosting charge. So basically this is very ideal Thingsboard for practice purpose or at academic level, where you can perform all the capabilities which AWS, Azure or Google has, but for the IoTs, not for other things. So this Thingsboard is specifically designed for the IoT system. Now, what kind of facilities these cloud functions provide? Generally, these are used for device registry. The IP-enabled devices are registered here. Second is rule engine. For example, what things we have to do if certain condition is matched. That thing we can set in terms of programming, and that is nothing but our rule decision. Analysis based on large number of sensor data. We can analyze that data and get to a conclusion, to reach at a conclusion to perform certain actions. So that analytical part is also handled by cloud system. Alert system is also there. Different CloudWatch or Google Analytics services are available, and they generally give the information regarding CPU utilization or even the failure of any specific IP-enabled sensors or device. Different dashboards are also there where we can see the graphs and analyze whatever data coming from this sensor. So these are about the cloud platforms. Now, edge computing. So generally what happens, this computing or decision making data processing happens at cloud level. So if some data is sensed with the help of sensor, that data is being sent to the cloud system over the communication network, and there the processing happens. But what if that processing happen near the device? So that will save a lot of bandwidth, lot of energy required to transmit that data. So that localized computing is nothing but the edge computing. And that's why if you see the example where smart CCTV processed video locally using the edge AI, for example, at company entrance, if our face recognition happens, it only detects that face locally and sends the decision to the central system, open or do not open. It do not send whole image to that cloud system, saving lot of data. It take the decision at local level near our sensor or near our source devices. So some of the advantages is it is a faster and it works without even internet. It can be Bluetooth enabled. It reduces the unnecessary cloud cost because each service on cloud platform we have to pay certain charges for it. Now moving to the next slide. So what are the challenges we generally have in our IoT systems? And this is the biggest concern because of which it is not growing at that level at which we are expecting it to grow. Okay. So basically, whatever application we are using through which we operate this IoT device, they may suffer due to weak passwords, certain password criteria. That is true for every system, not only for IoT enabled applications. For every system, the weak password may cause the intruder getting into our system and taking the control of different IoT devices, or introducing the malware, asking for ransom. So those are the consequences, but this is the one of the reason that is more prominent in IoT devices, because they are integrated with large amount of thousands and millions of sensors. Second is similar device hacking. Since these sensors, actuators are large in number and spread across the maximum geographical area, so someone hijacking those devices or tampering with devices, that probability increases. Even the data leak, because of that, since they are large in number, the data leakage is also possible. Fourth type of threat is botnet. Botnet is nothing but it is a very famous attack, Mirai attack, where what hacker try to do is it migrate through our system and it find out the weakest IoT devices, and after identifying group of weakest IoT devices, it create a network of that weak IoT devices. And now further he can either get that private data, sell it, or use it for his use, or even he can ask for ransomware to free those IoT devices. So this was a very famous attack in 2016, where a lot of big firms, big fours, or Google, Meta, all those were affected by this specific attack. So the such kind of things also happen. Now, the general security practices that we can follow in order to avoid any security threat is encryption. That is end-to-end encryption of the data, from sensing the data to processing it on cloud, or transmitting it via communication network. That should be end-to-end encrypted, so that even if intruder or hijacker intercept the data in between, then he should not perform some mishap with that specific data, because that is in encrypted format, and that should require decryption, and decryption is generally done using the keys, private public keys. So end-to-end encryption is always a secure practice. Second thing is secure boot. In secure boot, whenever our IT enabled device is started, that time certain signature we can set, and if that signature is not matched, our IoT devices will not boot. So that is known as secure boot. A firmware update is generally a software that is being dumped into our hardware once, and that is not changed for a long time. So that may create a bottleneck, and timely update of that specific software is necessary. So firmware is nothing but the software that is dumped in hardware single time, but timely update is necessary to fix the certain things which are lagging. And last thing is network segmentation. For example, IoT is not a single system. It is a bunch of systems connected to each other, sensors, actuators, then communication network, then cloud, and then application. So it's better to segment them in a small unit, so that even one unit is compromised, then other unit still remains secure, or a hacker should not reach to the another segment. So that network segmentation is necessary. Now moving on to next slide, what are the application of different IoT devices? So generally smart homes, we all know that most of us have now Alexa, that is voice operated. Similarly, we have smart locks that can be opened using card, fingerprint, or even password. Second is smart cities, where smart parking and waste management can be done smartly using different sensors, IR sensors, where we find the vacant parking slot, or waste levels can be identified using the cameras. So that is the second thing. Third thing is smart aggregation, smart agriculture. We know that our geographical area is very huge. Climate and weathers are extreme at certain portion. So there the smart dripping system or moisture sensors are of utmost importance, because we can sense the humidity, and as per that water uses can be restricted. So this is smart agriculture. uh, Fourth is smart manufacturing, where predictive maintenance is generally done, because in manufacturing sector there are large number of big size machineries, and those machineries uh, decay over time. For example, certain problem arises in those machineries over the period of time. They emit more heat, they make more noise, or they heat up more than the usual. So there we can take a use of these sensors and predict based on that data, that when that specific machinery need maintenance. That maintenance can be uh, regular reactive maintenance or active maintenance. For example, if this sensing data is beyond threshold, then we can perform maintenance of that device, or that can be scheduled maintenance. For example, we have a certain data from our past experiences, and the timely maintenance is needed for that particular machinery. Now, the healthcare IoT wearables, we know the smartwatches are all around us. They are monitoring different heart rate, or even our step counts, and all those things are reality. Those are not thing of future. So these smart wearables is also one of the trend or application of IoT. In retail sector also, smart shelves or inventory sensors to guess the current or to predict the future or even current inventory in the system, where RFID tags can be used, or even cameras can be used, or even weight sensors can be used to judge which shelf is full or which shelf is half empty, which need refueling. And those data generally then transmitted to our ERP system, so that procurement and sourcing of those limiting stock can be done. So, and the last application is our automotive. We know that our different latest cars are coming with ADAS level 1, 2, 3, where different sensors are there. And uh, in India, that is limited, but we know that self-driving car is no longer a future. That is a reality. So different kind of sensors and processing unit are used in this automotive industry as well. Now, generally, what is smart system? The system that senses, process, decides, and act automatically using AI. Sorry, IoT devices. But now these IoT devices are also enabled with the AI. That is small uh, AI model or mini LLM is also attached to these IoT devices, so that they can make certain decisions locally. The example is smart irrigation, where if soil moisture is less than the certain threshold amount, then system open the water valve and inform the farmer and stop after the certain moisture level is reached. So these are nothing but smart system. Uh, this is the same IoT plus AI. It is known as AIoT. AI brings intelligence to the IoT. We saw the predictive maintenance of the different machineries. Similarly, the face recognition, generally in different organization, we see that attendance system is based on face recognition. And instead of, as I already explained, instead of sending all this data to centralized system, locally using small LLMs that can be judged which is a valid or authorized entry, or which entry has to be restricted. Similarly, voice assistant, we all know the Alexa, which is a voice operated device, but certain AI Alexa versions now coming into market, they are AI enabled. The way ChatGPT responds to us, similar way, This Alexa can also respond specifically if that is AI enabled. And energy optimization. Different vibration and temperature sensors are used to judge that which specific area is heating more, or which has light requirements, which do not have light requirement. And that prediction can be done using small LLM if it is trained with good amount of data. So that energy optimization can also be achieved within this AIoT. Now, real world case studies. I know these are not case studies which are applicable to the large geographical area, because different challenges in our country and all those things. But certain localized area do have the smart parking system, smart manufacturing, smart city garbage bins. Uh, so where the sensors in the smart parking system, sensor detect the empty slot and sends to the cloud. An app shows the available parking to that specific car. Generally, IR sensors are used in this system. Similarly, smart manufacturing sensor detects machine vibration, AI predicts breakdown and maintenance schedule early. As I already explained, that is a active and there is a reactive maintenance. Active maintenance is a scheduled maintenance, reactive maintenance based on the data that is provided by our sensor. Now, third one is the smart city garbage bins.
Hello, Sushil sir.
Hello?
Yeah, I think his connection is lost. I will
Okay.
check with him.
We'll wait, sir, 2 minutes. I think sir will join.
Yes, yes.
Yes. सर त्यांना कॉल करा ना सुशील सरांना.
Yes, yes, he is joining. Hello, everyone. Sir is having some problem. He will be joining within 5 minutes. He is having some network connection problems. Please wait.
Hello, am I audible? Hello?
Yes, sir, you are audible.
Okay. Okay, Dhawan sir, when you lost me, I was not aware.
I think 10, 15 minutes. I was trying to call you.
Okay,
Uh,
okay.
so you can start with the slide number, real world case studies, I think.
Okay, okay.
Yeah, the presentation is visible, sir.
Okay, okay.
Okay.
Okay. So these are some of the market growth. Am I audible, Dhawan sir, now?
Yes, sir, you are audible. The
Okay, okay.
presentation is visible.
Okay, okay. Sorry.
Okay.
So these are the market trends from 2024 to 2034. We are expected to grow in this range in terms of these IoT devices, and this is the expected CAGR, that is 16.25 till the 2029. These are some of the players who are available, which are offering specifically AI-enabled IoT devices, because most of these players are in software industries. So they are providing the IoT devices with the AI flavor. Similarly, this AI IoT growth is expected to be 41.28 billion till the 2029. Now, these are the trends. For example, 5G IoT for very high speed and low latency. AIoT, artificial intelligence enable IoT devices. Digital twins. We know that it is an exact virtual replica of our hardware system. For example, in case of mobile testing, APM is there, where you can see the simulator and emulator. That is exact replica of your phone on the laptop. Similar way, in manufacturing industry, large machines can be or large machines replica can be created on your laptop. And what if questions can be answered using that replica? What if I give this much load? What if I give this much input? That kind of question can be answered, and we can be prepared using these digital twins. Smart wearable wristwatches and fit bands. This is also in trends. Industrial IoTs, we already explained in terms of digital twins. Blockchain for the secure data transmission. We can use the blockchain technology unless and until majority of blocks are in your favor, then you cannot tamper the blockchain. So that is a secure way of transmitting data using IoT. Challenges is security. That is hijacking hacking may happen in terms of if data is not encrypted. Similarly, scalability. Large number of data through millions sensors reaches as cloud system. So our cloud systems should be scalable either vertically or horizontally. So that scalability should be considered. Power consumption is also one of the challenge because of limited amount of batteries available at near the source. Standardization, there is no specific standard for the IoTs. The way Selenium is used for software testing, it operates on JSON wire protocol. And that is why different browsers can develop their browsers keeping that specific standard in mind. But here in IoT, such kind of standardization is not there. There are different network providers. Each sensor or even controller manufacturer is coming with their own standards. So that standardization is not possible. That is one of the challenge. High IoT volume data storage, millions of sensors sending the data at every second, every minute. That is one of the challenge for storage at cloud level. That increases the cost of our cloud services significantly. And it is a network dependent system. So any latency or we can say any outage in the network will significantly affect the IoT system. The future is of smart cars. Every day, some or other car manufacturer coming with uh, new technologies. ADAS 1, ADAS 2. We are very well aware about. Drone delivery that is already happening in China, but that will also happen in India to the large extent. AI-based homes, the smart home automation already exists, but if it is to be completely automated, then based on day or day or night, light should be turned on, turned off. Those kind of functionality can be achieved using AI. Fully automated factories. If most of you may be aware about dark factories in China, where not a single tube light is on and inside machine operate 24/7. So those using robotic arm and many other automated tools. So those fully automated factories is also one of the future of IoT. Personalized health in terms of Fitband or smartwatches. And last thing is hyper-connected smart cities. These are some of the futures of IoT. Cost structure is 25% hardware, 20% connectivity, 40% cloud and software, and 15% is maintenance is required. So there is a significant portion apart from the software part. So that is one of the challenge for IoT system for not growing up to the level of software industry. Hidden cost also involve data charges. We need data for the wireless communication. Remote updates will also take longer time, manpower. Battery replacement will also take longer time and manpower. There are certain downtimes whenever you want to service that hardware. So that is also one of the hidden cost. Now, IoT project failure reasons: poor architecture, that is scalability is not decided at the beginning. Network segmentation is not decided at the beginning. So that can be one of the reason. No real ROI because, as you know, apart from software, a lot of hardware is involved, and hardware required maintenance, manpower. So most of the players hesitate to enter because of this really less ROI. Network issues, there are certain downtimes, network latencies are also there. So it is network dependent system. So that issue is also the probable cause of failure of IoT project. Wrong sensors use, scalability is not planned in advance, even the security ignored. That can lead to the hacking of our personalized data and using it for the uh, uh, wrong reasons. Okay, that can be a failure reason. And similarly, you need a skilled engineers who can maintain these hardware and proper integration with the software system. So that is also one of the reason. Now, skill required, generally these are the skills on which we can train the students at least at basic level. One of the programming language, embedded C, Python, but a different microcontroller board operate on C, C++. For example, Arduino we can use. So apart from this embedded C or Python, we can also, if you want to start from basic, then C, C++ is also good thing. Network basics, what are the IP addresses? What is IPv4, IPv6? Which one is used for IoT? What is the range? What will be beneficial for using? So those can be taught to the student. Cloud computing basics, idea, at least the basic services. What are virtual machine, EC2 instances? What are Lambda function? What are S3 bucket? So these can be taught. MQTT and REST protocol plus Modbus protocol. These are protocols specifically designed for IoT, first and third one. But the middle one we can use for APIs also. But this MQTT, that is message queuing, telemetry transport, and Modbus, it is generally a master and slave architecture based protocol. So that is specifically designed for IoT system. And AI ML foundations. So basic LLMs, promptings, agents, agentic communication. So these kind of foundation is required for IoT engineer. PCB design fundamentals, databases, Linux, shell scripting. These are the required skill of IoT engineer. What college must train students in? So we can start with the basic microcontroller based system such as Arduino or ESP32. The ESP32 is specifically designed for IoT system. They operate on C++ language. They have their own IDE. So we can connect the sensors, actuators to it, program in our IDE, and at least do some switch on, switch off operations. So sensors plus hands-on IoT project using these Arduino ESP32 Raspberry Pi. MQTT basics, cloud integration basics, or basic robotic, Edge AI, secure coding, data engineering basic, capstone IoT project. For example, end-to-end from that capstone IoT project, end-to-end project can be done. So these are the IoT applications: home, city, environment, energy system, retail, logistic, industry, agriculture, healthcare. Here, the IoT systems are used. In home and home automation, smart lighting, smart appliances, intrusion detection or smoke gas detection, their IoT system can be used. These IP-enabled lights can be used, which saves the energy in daytime by switching it off. So these are the smart lighting example. Smart appliances, washer or dryer, they will notify when the washing or drying cycle is completed. Open Remote is one of the open source platform for the smart home and building that can control various appliances using mobile and web application. Okay, it consists of controller, designer, and control panels. So intrusion detection is, for example, if unauthorized entry try to get entry in our home, then cameras and sensors will detect it and will notify through SMS, email, or grabbing its image and sending it through our email, sending it on our email. Smoke gas detection. So ionization or detection technique is used by this smoke gas detector. A lot of it is already provided by different developers on ready-made flats. So this can be used in our home automation. In cities, smart parking, smart lighting for road, smart roads, or structural health monitoring, surveillance, or emergency response. These are some of the functionalities we can achieve through IoT in terms of smart cities. So finding the parking spaces in crowded city, so that can be done. The empty slot can be detected using our IR sensor, and that specific slot is then allotted. Similarly, smart lighting, controlling the lights at daytime or nighttime, and dynamically controlling it in terms of foggy day or festival, that can be achieved using smart lighting for roads. Then smart roads also provide information on driving condition, travel time estimation, and alerts. So such information can help in making the road safe and help in reducing traffic jams. Information sensed from roads can be communicated via internet to cloud-based application and social media and uh, disseminated to the drivers who subscribe to such applications. Structural health monitoring. It uses a network of sensors to monitor the vibration level in structure. As we already saw in even manufacturing sector, this can be used for machineries and assess the health of the structure. By analyzing this data, it is possible to detect crash or mechanical breakdowns and locate the damages to structure, also calculate the remaining life of the structure. Surveillance is also one of the application in smart cities, where infrastructure, public transport, and events in cities is surveillanced with the cameras. And these large number of video cameras are connected to the central system where they can be monitored, and the video feed from surveillance camera aggregated in cloud-based scalable storage. So that is one of the application. Emergency response. So IoT system can be used for monitoring critical infrastructure, cities such as uh, buildings, gas and water pipelines, public transport, and power stations. So based on any emergency, the alerts can be sent to the public, or if any traffic is there, that can be rerouted, or evaluation of any affected areas can be analyzed using these IoT systems. In terms of environment, weather monitoring, air pollution monitoring, noise pollution monitoring, forest fire detection, or river flood detection, that can be also achieved using IoT system. Humidity, temperature, or pressure can be monitored, and that data can be sent to the cloud-based application. Okay. This data is collected and visualized in cloud-based system, and decision can be made based on this specific data collected. In terms of weather alert, what will be the weather forecast that can be done. IoT-based air pollution monitoring system can monitor emission of harmful gases also by factories using different kind of sensor. So regarding pollution, certain decision can be made using this data collected. Noise pollution also that can be minimized using different kind of noise related sensors, and noise level of different cities can be mapped, and number of noise monitoring stations that are deployed on different places in the city. So collected data is then aggregated to generate a specific noise map and then act upon it. Again, forest fire detection that can also be done using IoT based devices at different locations. Nodes are deployed using which it collects the data, humidity, temperature, again light level, and at the early stage this fire can be prevented. Similarly, river flood detection, the motion or velocity of the water, levels of the water, that can be sensed using our different sensors, and that will also at the early stage river flooding can be detected, and evacuation is also possible nearby for the nearby areas. In energy system, there are smart grids, renewable energy system, and prognostics. These are some of the application of IoTs. So smart grid technology provide predictive information and recommendation to utilize their suppliers and their customer on how best to manage power. Smart grid collect the data regarding electricity generation, electricity consumption, storage, distribution, and equipment health data. So by analyzing the data on power generation, transmission, and consumption of smart grids can improve the efficiency throughout the electric system. Storage collection and analysis of smart grids data in the cloud can help in dynamic optimization of the system operations, maintenance, and planning. Cloud-based monitoring of smart grid data can improve energy usage level via energy feedback to users coupled with real-time pricing information. Condition monitoring data collected from power generation and transmission systems can help in detecting faults and predicting outages. Similarly, in terms of renewable energy system, due to the variability in the output from renewable energy sources, the integrating them in the grid can cause grid instability. Okay, and reliability problems. So IoT-based system integrated with transformers at the point of interconnection measure the electrical variables and how much power is fed into the grid. To ensure the grid is stable, one solution is to simply cut off the overproduction. So prognostics, IoT-based prognostic real-time health management system can predict performance of machines of energy system by analyzing the extent of deviation of the system from its normal operating profile. So in the systems such as power grids, real-time information is collected using specialized electrical sensors. So those are PMU sensors. So analyzing massive amount of maintenance data collected from sensors in energy systems and equipment can provide predictions for impeding the failures. In retail also, inventory management and smart payment can be done using this IoT system. Smart vending machines can also be set up in retail. So they also use the IoT system. So RFID tags are used. Even the weight or the camera pictures of the shelves are used to manage the inventory. So NFC tags, that is near field communication, so that is used for generally 10 centimeters of distance. So our NFC tags can be installed on our phone, and directly within 10 centimeters of range we can make the payment. So that smart payment can also be achieved using this IoT system. Smart vending machine, so based on the inventory available in the vending machine, it can judge the expiry date of any specific item, or give the prediction, give the suggestion that this specific inventory is expiring, so reduce its price. Such kind of smart vending machines can also be used in our retail system. Logistic, that is fleet tracking and shipment monitoring and remote vehicle diagnosis. There also this IoT system is used. GPS technology is used for tracking the fleet in our tracking the vehicle in the fleet, and based on that decision is made which route to be taken. Similarly, shipment monitoring solution for transportation systems allow monitoring the conditions inside the containers. So there also IoT applications are used. Remote vehicle diagnostic, it can detect fault in vehicles or warn of impeding faults. Again, it is a predictive diagnostics can be done for the vehicles using the IoT system. In agriculture also, smart irrigation, greenhouse control, different humidity sensors, temperature sensors, and different actuators, valve or motors are used for smart irrigation. Similarly, the greenhouse, where the specific environment conditions are to be maintained, there also different sensors can be used to control the greenhouse effect. In industry, again, machine diagnosis and prognosis, indoor air quality monitoring, uh, again, vibration sensors, noise sensors, these can be used here. to predict the maintenance of the systems. Again, AQI, air quality index there also, but not outside, within the organization. Different sensor can be used to collect the data and adjust the atmosphere, ambient atmosphere, as per that. In health and lifestyle, wearables and fitness monitoring devices, those are generally used, belts and wristband. Those we already discussed. So yeah, that's all, sir, from my.
Thank you, Sushil, sir.
Thank you.
Yeah, it's a nice session on Internet of Things and its applications in real world and smart grid and energy systems. So I thank Mr. Sushil Bagal for his presence and innovative speech on this Internet of Things and smart systems. So thank you so much, Sushil, sir.
Thank you,
We'll
thank
be
you.
in touch for the next coming days for these again FDPs. So thank you
Sure,
so
sure.
much all the participants for your patience learning, and Sushil sir, More sir, and Biradar sir.
Sir, if the participants want to interact with the Sushil sir, now the forum is open. Participants, please unmute yourself and interact with our speaker, Sushil sir. Okay, Sushil sir, we will share your details with the participants. So in future, if they want to interact with you, they will contact you, sir.
Sure, sir, sure. Thank you very much, sir.
Thank you, sir.
Dear participants, we are having the next session, the second session of this last day, 6th day of FDP. So we are having the Dr. Vasudev Madhav for this particular session. So I think we will take a break of 5 minutes. Sir will join within 5 minutes. Now it's 3:26. So exactly we'll start the session 3:30. So meanwhile, sir will join, then we will start. Good afternoon, sir. Dr. Madhav, sir, good afternoon.
Good afternoon, sir.
Yes, yes. So can we start, sir?
Yeah. Shall I upload?
Just a minute, sir. I will give the introduction, then you just share your screen. Once again, good afternoon to all the participants for this second session of our 6-day online ATAL FDP. Now we are with us with the Dr. Madhav, Dr. Vasudev Madhav, sir. So it is my great pleasure, honor to introduce Dr. Vasudev Madhav, sir. He is an eminent academician and accomplished researcher and the leading expert in the field of biomass gasification, waste to energy, and sustainable energy technology. With an impressive career spanning over the 26 years of experience, Dr. Madhav has made the remarkable contribution to the research, innovation, and the capacity building in the domain of clean and renewable energy. Dr. Madhav holds a PhD from prestigious Indian Institute of Technology, Bombay, along with the strong academic foundation through his BE and MTech degree. His research expertise over the several cutting-edge areas, including solid fuels combustion, small and medium-scale gasification system, environmental impact assessment, sustainability assessment, and the circular economy-based energy solution. Over the years, Dr. Madhav has guided and mentored a large number of scholars, including 9 PhD candidates awarded and 4 are ongoing, along with the 15 MTech theses and 22 BTech theses, demonstrating his strong commitment to the academic excellence and the talent development. One of the remarkable features of Dr. Madhav's career has been his leadership in the establishing high impact research center as the project coordinator. He has successfully conceptualized and created the 3 major research centers: one Marine Technomont Center for the research in the waste recycling and the circular economy, Petronet Center for the renewable hydrogen research, and third one, Center for the Sustainable Energy Engineering. He has also played an instrumental role in the supporting the creation of a Center of Research facilities with the total sanctioned budget rupees 550 lakhs, enabling to procedure to the state of art of equipment. Dr. Madhav research output is both prolific and impactful, with the 30 plus publication across the top tier 1 Q1 ranked international journal. His work has appeared in the high reputed journals such as Advanced Energy Material, having the impact factor 30 plus, Renewable Energy, Energy Conservation and Management, and so on. His contribution have leads to significant advancement in the sustainable energy solution and engineering design, a testament to his innovative outlook in his awarded patent in May 2018. Further highlighted his drive for the translational research and the technological innovation. In addition to his research accomplishment, Dr. Madhav has been the recipient of several prestigious recognitions, such as Marine Technomont Faculty Research Fellowship for the Sustainable Development in 2022 and 23, AICT PhD Research Fellowship in 2004 to 2006 and 2010 to 2013. Awarded as a faculty advisor for the student team that secured the first prize in competitions such as the Challenge Chaitani and Virtual Baja Vehicle Design. His cumulative project funding stands at an impressive 444 lakhs, reflecting his consistent ability to attract the large-scale research grant and develop the collaborative industry academic initiatives. Dr. Vasudev Madhav is deeply respected for his interdisciplinary expertise, visionary leadership, and unwavering commitment to sustainable technological advancement. His passion for the research, combined with his academic influence, and continue to inspire the student, researcher, and faculty members. We are privileged to have him as a today distinguished speaker. Please join me in the warm welcoming Dr. Vasudev Madhav, sir. Sir, now the session is yours. You are having time up to the 5 p.m.
Yes, sir. Thank you. Thank you for giving detailed introduction. So, thank you also giving me an opportunity to present a lecture on. So I'll have a little change. It is like clean energy from waste. So how it can be utilized for various applications. So I'll share my presentation now. Is it visible, sir?
Yes, sir, visible.
Yes, sir.
Is it gone to presentation mode?
Yes, sir.
So, good afternoon, everyone. So,
Sir, it is not in presentation mode.
presentation mode, it is not coming.
Yes, sir.
Now, sir,
No, sir. I think you stop that sharing and again you share the screen.
now it has come, sir. Hello.
Sir, please place the F5 so it will become, I think.
Full screen it is coming.
No, sir. No.
So, what is the problem?
Sir, on top side in menu, that slideshow is there, so you can place there. Sir, on the top side menu, the at transition, animation, slideshow, record.
Shall I share it to you, sir?
Hi, sir, no problem.
This,
Yes, yes, no problem. You share me, I will.
I don't know where I'm going wrong.
Yes, yes.
Shared, sir, WhatsApp.
Yes, sir, I will take that. Sir, it's ready, I think. Visible.
Yes.
Yes.
Yes. Sorry for the delay. So I'll start. So here the topic is like waste to clean energy technologies for many applications, so including the automobiles. So thank you. First of all, I'd like to thank the coordinators for giving an opportunity to deliver the lecture online. On the occasion of this ACT training program on emerging trends in renewable energy, smart systems, and climate change mitigation. So here, first of all, I'll give brief discussion about waste management technologies. So here, whatever the waste available, from that, so we are converting energy. So first of all, so I consider the available waste as a resource. So then, based on the available technologies, so we are converting this into useful energy. So with this research, we developed some projects or PhD projects and tech projects. And also we received a substantial amount of funding through CSR. So it is like teaching course rather than sharing my experiment or experience. So here I am sharing the experience, not teaching. So experience in the sense based on available resources. So available resources inside the campus, it is like waste resources. I consider waste as a resource. So municipal solid waste. So there are like various types of wastes are available. So inside the campus. So it is like maybe household waste or commercial waste or waste from markets or waste from street sweepings or waste from horticulture or many other kinds of waste emerging from homes, schools, colleges, as well as hospitals and commercial establishments. So as far as the waste is concerned, sir, I'm in slide 4. As far as the
So
waste
please
is
tell me the
concerned,
next slide, so I will be in
yeah,
the next slide.
yeah. Yes. So as far as waste is concerned, so there are huge amount of the waste is being generated, about 2.01 billion tons of municipal solid waste generated worldwide, and also out of which about 63 million tons of food waste. And there will be estimation, so about 3.4 billion tons of MSW produced in 2050. So per day, only 13.5% is recycled and 5.5% is composted, and 40% of the food waste is not managed. Next slide, sir. So if you consider this estimation, so global annual waste generated, so about earlier it was about 1.3 billion tons, and in 2025 it is like plus 70%, it is increased 2.2 billion tons. So the cost involved in management of waste is also increasing. So waste generation is doubling, and also the cost is also increasing. So next slide. So here, if you see this slide, the state-wise waste generation. So for example, in Maharashtra, it's about 22,570 metric tons per day, and Karnataka about 10,000. In that way, different states, large amount of the waste is being generated. So here in this Indian cities, so food waste, garden waste or garden trimmings, biodegradable waste, or which contributes about 50% of the waste. Further, there are other waste, glass, metal, plastic, or clothes, paper, and construction materials is also one of the waste generated. So here, if you see overall waste generation, so individual is concerned. So individual municipal waste generation daily is about 2.5 kg in future. So today it is about 0.4 kg. And today around in India, today's MSW generation is about 55 million tons. And in future may 365 million tons. So here 95% of waste is not properly processed, going to landfills or lying untreated in nature. Next slide, sir. So if you not manage the waste, or what are the impacts? So all of us are aware about these things. Open dumping or open burning. So open dumping is like municipal solid waste or healthcare waste, construction and demolition waste, or there will be like health hazards, disease vectors, and also spread of infections may also occur. So there are open burning of used tires or waste electronic materials, equipment, batteries. We don't recycle properly, so it will lead to marine litter or water, soil, or air pollution, etc., which indirectly leading, if you are burning, so indirectly leading to global warming. If you are dumping this organic waste into the dumping yard, so upon decaying, it will produce methane. So methane, which is more harmful than other chemical, one of the greenhouse gases. So which in turn leading to global warming. Next, sir. So here, what we have done is we estimated the waste inside the campus. So increase in the intake of students, change in the consumption pattern or social behavior, and solid waste is being increased. Someone is raising hands. Anything? Okay. Any questions? Like raised hands, or questions will be taking later, sir.
So question will be later.
Okay. So the problem of this MSW inside the campus, it is like mosquito breeding, pest infestation, breeding ground for disease vectors, etc. So therefore, we thought of using these technologies, available technologies for managing the waste, and through that we will carry out the advanced research also. The first, what we have done is, so what are the wastes available inside the campus? So it is like an ATK campus means it is a 300 acres of land, and here 6,000 students staying in the hostels, faculty and staff are residing in the quarters. And also, what are the dry waste and wet waste is being generated? What are the sources of waste? So surrounding of hostels, offices, mess, canteens, kitchen, staff quarters, guest house, or dispensary means healthcare center, or construction sites of waste. So then we plan how we can manage these kind of waste. The waste generated inside the campus, if you don't manage properly, leading to environmental hazards, or incineration is also creating problem. If the waste is disposed in open, it will be creating problems. So breeding sites for insects, vectors, snakes, rats, etc. It will increase. Therefore, we plan to manage this kind of waste. So next, sir. So here, first of all, we estimated what are the wastes available inside the campus. So it is like teacups or mineral water bottles, etc. And how many numbers it is available. Next, sir. So distillery bottles or teacups, or how many bottles, how many paper box waste. And it is like related to particular shop. One shop, we can, how many kgs of waste we can get. So in that way, we estimated other waste also. The next. So this is like the waste dumped near the hostels. So it is like waste collection center, waste collected and segregated near the waste dumping yard. There we can get both plastic as well as paper waste and recyclable waste. Next, sir. So then again, online shopping item materials also will get. Next, sir. So some of the waste generated in our cooperative societies. Next, sir. So some plastic waste, toys, waste from the campus. Next, sir. So food waste from the campus, vegetable waste from the campus. So plastic waste also from the campus. So then we estimated what are the biomass waste is available. So in order to use the technology, it is like technologies we focused was one is food waste to biogas, another one is food solid waste to syngas, third one is plastic to oil. So in that way, we were planning. Next, sir. So here, what are the other wastes? So in addition to the waste generated from the homes, hostels, or cooperative societies, what are the other wastes generated inside the campus? So again, the coconut palms. So that will produce around 15 to 17 foot long leaves, and also it is like 1 year we can get around 10 leaves in that way, and it is also like mature leaf around 3 to 4 meter long, or it is having 200 250 leaflets, etc. We estimated. So next step. So what is the husk? What is the weight of the husk? What is the shell weight? What is the kernel weight? Or what is the water content in that weight? So what is the coconut consumption in one mess, etc. And how many kgs of waste is being generated? So in that way, one single coconut, what kind of waste we can get, and what will be the total waste, dry waste, what we can get from a coconut. That also estimated. Next, sir. So coconut husk and coconut shell available inside the campus. Inside the campus, there is also a that is coconut garden. So we'll generate a lot of coconut shell, and we'll sell these coconut to the messes. So inside the campus, we'll get a lot of coconut husk and coconut shell inside the campus. Next. So other waste related to coconut tree. So next. So and other waste related to wood waste available inside the campus. So it is from the branches of the trees and palm tree leaves, etc., dried leaved, etc. We focused on these technologies. Then we also estimated what are the leaves available, dry leaves available, or wood logs found inside the campus, or heap of dry waste is found in the campus, and collected tree branches or during the Swachhata Pakwada or daily cleaning, dry waste and grass waste available inside the campus. So all these wastes are considered for the estimation of the dry waste inside the campus. Next, sir. So here it is. This slide shows the MSW generated per person per day. So around 450 grams. So we can say 0.45 kgs. So MSW composition, it is like 35% of total will be dry waste, and biodegradable waste around 45%. So organic and inner organic waste, that is biodegradable waste. Another one is inert silt and construction and demolition waste, about 20%. So bottom, so waste generated per person, so dry waste or biodegradable waste or inner silt. So it is, you can say about the dry waste is about 0.16, biodegradable about 0.2 kg, and inner silt at 0.09 kg. So number of students inside the campus, and accordingly we calculated the dry waste and biodegradable waste. So total about 2.5 tons of waste is being generated inside the campus. Next, sir. So biodegradable waste, that is coconut consumption, and also 11 messes running inside the campus, and biomass, what is the leaves, what are the leaves, and what is the wood, how many kgs we can get per month, and the dry grass, how many kgs per day, and what will be the total biomass waste generated, biomass availability. So this biomass waste, or if it is a organic waste, one technology is required, or biomass, if it is a dry waste, another technology is required. So wet waste is handled by anaerobic digestion process. Dry waste is being handled by gasification process. So here we actually determine it's approximate. So 40 to 50 kg, we have taken upper limit. From these are the waste collected from different hostel leftover food, that is organic waste collected from the hostels. So we estimated around 950 kgs of waste. 950 kg to, it was varying from 800 to 950 kg of waste. Next, sir. So total waste. So it is like food waste and biomass waste. So other waste, total waste, like food waste is about 67%, and biomass waste is about 13%, and other waste, clothes and construction demolition waste around 20% waste. So next, sir. So here the dry waste, it is like plastic waste, tires, rubbers, textile waste, and metals, glass and ceramics, paper, cardboard, and other waste. So that is considered. So here the plastic waste is one of the major wastes. So other wastes like technologies are different for processing. So it was like we considered only plastic in this dry waste. Next. So as per the solid waste management rule 2016, so we have to manage. So if you are a bulk waste generator, so if you are staying inside the gated community or inside the campus, so it is like buildings occupied by the central government departments, state governments, public sector, hospitals, universities, colleges, hotels, or commercial establishment. So which are having an average waste of around 100 kgs per day. So that will be, so that they have to manage. So therefore, we focused on if it is like average organic waste. So if it is average waste is about 100 degrees, so we have to manage those wastes. So hence we decided to initially we go for anaerobic digestion. So next. So all gated communities and institutions more than 5,000 meter square area shall within 1 year from the date of notification, they have to manage the segregation of waste source by the generators and facilities, collection of segregated waste, and hand over the recyclable materials to the authorities, municipal authorities. So biodegradable waste, so it is to be processed by the and disposed by the concerned institute or concerned organization. So residual waste shall be given to the waste collectors and or agency as directed by the local bodies. And I think same procedure is followed throughout the country. So next. So here the after estimating, so what are the methods we can adopt? So we can say that like different kinds of waste is available, different kinds of technologies required to manage. With one kind of technology, one technology, it is not possible to manage the entire waste. So here we estimated the waste inside the campus and what kind of waste. It is like organic waste, wet waste. You can say organic waste means wet waste. That is the food waste available inside the campus, and dry waste. So dry waste, wood waste, dry wood or rubber or dry wood or boxes. That is like online material supply boxes, cardboard boxes, etc. So dry waste, food waste, and so biodegradable waste. So here initially focused, that is dry waste and biodegradable waste. So in the biodegradable waste, there are two categories. So that is the food waste and biomass waste. So dry waste in the sense, so that is the recyclable materials, bottles, metal bottles, etc., metals or other waste. So waste segregation. So it can be sent into material recovery facilities managed by urban local bodies. Next is plastic waste in the coming under the dry waste. The plastic waste, and that can be baling procedure, baled and sold to the local bodies. And the biomass waste, so either we can make briquettes or briquette making briquettes and sell to the local bodies. And the biomass waste milling or making it a powder, then fluidized bed gasification, so generate the syngas, so that can be used for steam generation for cooking or hydrogen production. So in that way, we can utilize the whatever the waste available inside campus. So next step. So here the first we focused on managing the organic waste. So organic waste in the sense non-polluting. One is like composting, another one is generation of the gas out of it. So we focused on generation of the gas, so that gas plus slurry, so that is the compost, or so biogas technology. So anaerobic digestion can give us, one is gas, that is methane, that is CH4 plus CO2 biogas, and another one is like in that also we can get manure. The slurry is considered as a useful manure, which is more powerful than that is NPK, nitrogen, phosphate, and potash, that manure. So here the biogas mainly consists of 55 to 65% of methane and 35-45% of carbon dioxide and hydrogen-less sulfide, and it is also having significant calorific value of about 20 megajoules per meter cube, which is lesser than LPG, but it is meeting the requirement of cooking, not exactly for all the items. It is like heating water or preparing tea or preparing the boiling eggs, preparing biryani, etc. It is suitable for these kind of cookings. Next, sir. So here, 1 meter cube of biogas can replace other sources of energy, that is about 0.52 liters of diesel, 0.62 liters of kerosene, 3.4 kg of wood, or 12.3 kg of cow dung, eggs, and 0.43 kg of LPG, 1.46 kg of coal, and 4.70 kilowatt of electricity. So in this way, we can replace. So here we are mainly using it for cooking applications. Next, sir. So here the initial biogas plant. So we plan. So it consists of a digester, the main reactor, and along with that, so shredder, in order to shred or reduce the size of a biomass or organic material. So some, for example, food waste, in the sense it consists of chapati, leftover food chapati, some hard materials. So that need to be pulverized. So then it is feeding into the mixing tank through the. Then it goes to hydrolyzer. So hydrolyzer, it will be like 3 to 3.5 meter cube size, and there it will be lying there for 14 days. Then it is supplied through the mixing tank to the biogas digester. So it is like by the biogas digester, another 14 days it will be there. So then total of 28 days, this biogas will be generated. So generated biogas that contains 55 to 65% of methane, and remaining is CO2 plus some H2S. So there is a gas purification system and there is also a twin balloon system for the measurement and management of the gas and the biogas. So what we are getting is about here it is like this is 1 ton photograph, 1 ton organic waste biogas plant. So we'll be getting around 35 half of it. This is the biogas plant. So here you can see the digester and storage tank. Yellow color is a storage tank and big steel color structure. Beside that, this small shredders hydrolyzer tank is also placed. Behind the biogas plant, it is our one of the hostel mess. So for that, we are supplying the energy. So this is like skid mounted technology. It is not earlier like gobar gas plant. It was kept underground, and that time there is a like KVIC design or Janata biogas plant designs were most popular. So nowadays these kind of small biogas plants are installed or developed by some companies. So here we took technical help from GPS Renewables. So one of the renewable energy supply company located in Bangalore. So sorry. So next, sir. So this was some of the photographs of inauguration. Next. Sir. So it is like some news published in the newspapers. Next, sir. So this was like initiation of one alumni. So 1981 batch alumni has donated this. So initially we started this plant in the year 2018. Started in the sense proposal. Proposal was submitted to some alumni batch. So they gave us some 1 lakh rupees so to start. But however, we could not collect the money. So 2018-19, we approached alumni, approached some funding agencies. So we got around 15 lakhs. But the actual cost of this plant was around 40 lakhs. So we were approaching the agencies and companies, etc. So one of the alumni from 1981 batch is Shri Milind Baridar. He is the vice president of this Technomont Private Limited. So he informed us that through CSR we will be able to support, entire plant will be supported. Later he supported us in getting the plant as well as some research projects. Next, sir. Next, sir. So this is how it is commissioned. These are the waste on the left side collected from various messes of NITK, and then it is the burner, and we are getting this blue flame, and it is being whatever the waste generated inside the hostel is being utilized inside the campus itself. So this is the help from the companies and as well as alumni. Next, sir. So this is like details of some gas generation. What is the LPG equivalent? So November, so up to 2023. So what is the total amount of the gas generation? What is the total amount of the waste processed gas produced, and what is the LPG consumed, etc. Details. Next, sir. This is similar LPG equivalent biogas. Next. So next, so our honorable minister visited the plant and also appreciated our efforts in utilizing this bio-waste recycling pilot plant, and also suggested us for future expansion of these plants, what we can do for the country. So from biogas to any other fuels. So later we took up this research into different directions. So interdisciplinary research. So initially our plan is to just to generate the biogas and utilize. Later, we focused on utilizing this technology for generation of the hydrogen. So here we have also used this facility for giving the demonstration of for nearby schools. These photographs are nearby schools, and also for our BTech students and Tech students demonstrations, and Kendriya Vidyalaya students, etc. And various schools students used to visit as a for the demo. Next, sir. So social impact of the project. So here food waste is being utilized, and which is solving three issues like waste management and energy demand and environmental concerns, and also 500 kg biogas plant. So it can generate about 5.6 kgs of hydrogen. So in this process, we can capture about 54 kg of carbon dioxide. So overall, total reduction of 12,554 tons per year of carbon dioxide emissions. So this project will be useful for disseminate this technology and also hydrogen generation technology. Next, sir. So it is like motivating the students. So focusing on this green energy solutions development for municipalities and local bodies, etc. And also for the overall sustainable development of the entire institute as well as local areas. We are also planning this similar work in Paradeep, Odisha. So there we have collaborated with the municipality, that is Paradeep municipality. Next, sir, Paradeep municipality. So these are some of the full-fledged sustainable development energy department at that point of time. So during the convocation, 2022, Sri Pradhan has visited and suggested us to go for this sustainable energy department because of our interdisciplinary research carrying out at NIT. Next, sir. So Paradeep, Odisha, that is like generation of biogas through anaerobic digestion process by using organic waste. So municipal organic waste collected from the various houses coming under that municipality and generating the waste, generating the biogas, and this biogas will be converted into CBG. CBG will be utilized for the preparation of food in Ahar Kendra. CBG means after compressed biogas plant. So after upgrading in the sense removing the carbon dioxide. So removing the carbon dioxide and increasing the percentage of methane in the gas, that is the compressed biogas plant. So 90 to 95% of the gas. So that will be utilized, stored in the cylinder under pressure. It is like compression up to 200 bar. So then it is utilized in the gas. So this company, Mare Technimont, it is a Mare group located in Milan, and which is having plants or projects all over the world, throughout the world, about existence in 55 countries. So with the help of the company, center is also created by means of MOU, that is Center for Research in Waste Recycling and Circular Economy, and involving 4 departments, and also they provided some research scholarships and various projects related to this. So we utilize this opportunity to carry out the research in this direction using three technologies and how we can solve the problem of waste. So next, sir. Here, different departments like mechanical department, chemical departments, and metallurgy, as well as chemistry department. So we came together for these projects. So mechanical department was focusing on biohydrogen through steam methane reformer and upgradation of biogas. So here in the chemical department, so bio CNG production So utilization of the gas and upgradation, and hydrogen materials is done by metallurgy department, and chemistry biohydrogen by means of green chemistry. So in that way. So next, various activities, and we also interacted with the next time. We also interacted with the local community to support the local community in waste management. So, and also we help them to manage their organic waste through our biogas plant. So generation of the biogas. So nearby 5 kilometer panchayat, village panchayat. So this is the photograph. Next, sir. So this is like in Odisha, we carried out initially starting the project. Before starting the project, so we carried out the feasibility study in Paradip. What kind of the project is suitable for the Paradip municipality. So we interacted with the officials, villagers, and also self-help groups, etc. Refinery, biogas plant at a refinery also visited. So then, next, sir. Then it is like we proposed the projects through this Myratechnomont company. So it is like bio-waste recycling project or green hydrogen production using RDF. So green or gray hydrogen production by using RDF, refuse derived fuel, or biogas supported EV charging stations, or skill development and women empowerment. So in that various projects we also finalized. Next, sir. So here, this is like one is available in technology. So biogas is not a new technology, the generation of biogas, but new technologies are coming, or new technologies have come up to generate the biogas. So from the biogas, so we want to convert. So here calorific value is 20 megajoules per meter cube. If you convert this into hydrogen, so that will be a future fuel, and it is a clean fuel. It can be utilized in the automobiles. A lot of research is going on. Some of the buses also coming, hydrogen bus, hydrogen battery. So hydrogen is utilized in the fuel cells. So in that way, so here the problem with this technology. So biogas is mainly produced through anaerobic digestion. So agricultural waste, bio waste, or municipal waste are being utilized. So here we can get biogas and methane. So by passing this biogas and methane through the reformer bed or catalyst reforming, so we can generate syngas. So syngas means CO plus H2. So here H2 can be separated out. So various types of catalysts can also be utilized. So here in the right side of the slide, there is a table. So it is like large scale steam methane reforming. The plant capacity about 150 to 300. The conversion efficiency is about maximum efficiency is about 85%. So small scale about 80%. So biogas reforming, so it is conversion efficiency is very low, 32%. So other technologies, the comparatively good. So main problem associated with this technology is carbon deposition, low reactant conversion, and high reaction temperature are main challenges here. So next. So here, the idea is like biogas reformer, development of the biogas reformer. So we have a food-based biogas plant. So it is generating methane or biogas. So about 35 kg per day. So is it possible to generate this hydrogen? Our plan was to generate the hydrogen. So idea is like with one step. So organic fraction of MSW can be utilized, or agricultural, industrial waste, or residues, bio-waste, sewage sludge can be utilized in these reactors. So that can generate biogas. So biogas can be converted into methane, or enriched methane can be converted into hydrogen by means of steam methane reformer. So here we floated the project on converting this methane to hydrogen. So one of our research scholars worked on this project. So he developed the technology, that is a steam methane reformer for this biogas plant. So he achieved around 70% of efficiency in converting this biogas into hydrogen. So accordingly, this results also published in one of the Q1 journals, Biomass and Bioenergy, is going to complete this thesis also. So here the idea is to support the Swachh Bharat Abhiyan. So implementation of this idea, if we're utilizing the waste and generating the hydrogen fuel for the future. So, and also along with this, so biogas plant also gives eco-friendly fertilizer, so which will result in cleaner cities and cleaner villages, meeting the requirement, power requirement, as well as fertilizer requirement. In future, in 2050, there will be a huge requirement for power generation, transportation, individual energy utilization, building, heating and cooling, carbon capture, new feedstock utilization, etc. So here anaerobic digestion can contribute in this direction to develop the clean energy or produce the clean energy. Next, sir. So these are some of the projects. Please skip, sir. Please. So next is like bio-waste management. So it is like, please next. So it is like our we involve in our campus, the faculty, deans and all involved in every Saturday of campus cleaning activity. So it is like along with the housekeeping staff, that is the one activity we do on Saturday. This is some photographs. Next, sir. Next, sir. So dry waste management. Next. So how we can manage the dry waste? So here the gasification. So by means of gasification, so we can convert this carbonaceous materials into producer gas. So producer gas consisting of carbon monoxide, hydrogen, and carbon dioxide. So here in the reactor, so this is also not a new technology. For 100 years, this technology is being utilized for coal gasification, biomass gasification, and waste gasification. So same technology can be utilized for generation of the syngas. So here both kinds of gas, if it is based on the gas cleanup method used, either we can generate cold gas or hot gas. Hot gas in the sense catalysts are used to convert this or remove the tar from the producer gas, because this gasifier generated gas, it generates producer gas. Producer gas means it consists of CO, H2 and a lot of tar compounds in that, the volatile materials. Because wood means some, when it is burning or gasifying, a lot of volatiles are released. That those volatiles comes along with the gas, which are harmful for the engines or some applications. If you are going for Fischer-Tropsch synthesis, that is production of Fischer-Tropsch developed a reactor. It is called as Fischer-Tropsch synthesis. In this, with the help of catalysts, we are converting this producer gas into diesel, green diesel, and then hydrogen also can be separated or substitute natural gas, methanol. So there are many applications related to producer gas. Further, it can be, if it is cold gas, it can be used in solid oxide fuel cell, integrated gasification, combined cycle, co-firing, gas engine, combined heat power applications, etc. Next, sir. So here the components of a biomass gasifier plant. So if it is like utilizing for small scale applications, so if it is like small scale applications in the sense less than 50 kilowatt electricity. So whatever the waste materials available, agricultural operations. So for example, rice husk, so that can be utilized. So that involves collection and transportation and storage and some processing. If it is like other than rice husk, there will be fuel processing, and then it will be stored. Then it will be fed into the gasifier. Then from the gasifier, it will be the gasification process will be carried out inside the reactor. Then the gas generated will be cleaned by means of water-based scrubbing. Water supply is required. Wastewater is being generated, and some waste materials also coming out of the gasifier. So then it will be cleaned gas will be utilized for thermal application, either for thermal applications. So thermal applications, aluminum rolling mills or mosaic industries, wherever heat is required. So then power generation. So it will be can be utilized in the IC engine coupled with the generator. So in that way, there are many applications. If it is small scale gasifier, that can be used for thermal applications as well as energy generation or electricity generation applications. Next, sir. And the plastic leaves available inside the campus. So leaves available inside the campus. So it is like collected and it can be converted into pellets by using some binders. So here we're adding some plastics, and it will be used as a binder for, and it can be utilized in the gasifiers. So next, sir. So small scale, this is like 1 kilowatt gasifier. It is for exclusively used for research purposes, students, and also demonstration purposes. This is 1 kilowatt wood gasifier. So here, exclusive setup mainly for gas cleanup studies. So there is a reactor, and there is a gas cleaning packed column. So packed column, and there is a biodiesel. So biodiesel is being utilized for gas cleaning applications, so that it can remove some of the tar compounds, etc. This kind of research, that is gas cleaning. The gas cleaning mainly for various applications. One of the application is IC engines. Next, sir. So this is like the pilot scale gasifier. It is like rice husk gasifier. It is one of the field studies carried out by us. It is in Patna. So they use rice husk for gasifying or producing the biogas. So in a downdraft gasifier, so around 35 to 60 kg, generate around 35 kilowatt electric. So they installed many gasifiers in the surrounding villages. In villages, that is husk power system. If you visit their website, you can get many details. And also they saved a lot of liters of diesel as well as kerosene. So in this way, they are generating the green energy and saving the environment. Next, sir. This is like layout of how the layout of gasification plant looks like. So there is a downdraft gasifier. So from the gasifier, the gas is generated. It goes to venturi scrubber. Water is used as a gas cleaning solvent. And next is like further gas cleaning and conditions. Charcoal and rice husk bed. Charcoal bed is also utilized. Then fabric filter is placed before supplying the gas to the IC engine. So there are a lot of ash, char or tar particulate matter is also produced. So here later bottom there are impingers, not measure the concentration of the gas, concentration of the tar in the gas at the gasifier exit. That is in the figure we can see A, and the clean gas coming out at D. Next, sir. So that is gasifier exit. At the gasifier exit, gas is measured. Next, sir. So next is scrubber exit. The gas is measured. What is the quality of the gas at the exit? And after cleaning, what is the quality of the gas before supplying to the engine? So if you supply the gas to the engine as it is, so it will be deposited. The tar will be deposited because initial temperature will be around 250 to 300 degree. When it reaches to IC engine, about 40 degree, 35 to 40 degree, these tar compounds will be condensed on the walls, and there will be particulate matter. So particulate matter disturb the movement of the or piston, liners, etc. And it also mixes with the lubricating oil. Therefore, viscosity, tar also mixes with the lubricating oil. Therefore, viscosity increases there. Therefore, before getting into the IC engine, we need to remove this tar, PM, particulate matter, ash. So that is a challenge. So a lot of research is going on in that direction, removal of tar from the producer gas and increasing the concentration of H2, CO and H2. And further, this is also utilized for municipal solid waste management, and plastic is also mixed with that. So plasmix, so MSW plus plastic, MSW plus plastic, plasmix fuel. So they're trying to increase the technology, develop the technology to increase the hydrogen percentage. So focus is generation of hydrogen, so up to 40%. Normally it is like in the producer gas, it is around 20 to 20% CO and around 19 to 20% hydrogen we can form. The remaining is other gas constituents. Next, sir. So here one of our research scholars developed a gasifier inside the lab. So it is like fluidized bed gasifier. Here we are using agricultural residues as a fuel. So it is like cashew husk, rice husk as a fuel. They are powdered in the powdered form. Through the screw conveyor, it is supplied to the gasifier. And here also our effort is to generate the gas and increase the percentage of hydrogen. So different combinations of the fuel. The specialty of this gasifier is you can utilize various types of wood waste or various types of sawdust or rice husk or cashew husk or cashew shell, etc. can be utilized in the powder form. It can be utilized in this gasifier. So generated gas, so it is a fluidized bed gasifier. So only powdered biomass will be utilized. So idea is to use agricultural residues, various types of the waste utilized and generate the gas, and how to increase the percentage of hydrogen in the CO in the producer gas. Next, sir. Next is about plastic management. So plastic is also one of the problem causing waste. If it is burns, it will be, most of the cases it will be burnt and it will be transported to the dumping yard. Approximately 4% of the world's oil and gas produced is utilized as a feedstock for plastics, and about 3 to 4% of them is used for their manufacturing. So plastics are not readily degrading, so very stable in the ambient environment. So plastic production has surged over 50 years. So 15 million tons in 1964 to 311 million tons in 2014, and expected to double again in the next 20 years. So because we are depending mainly on these plastics for various applications. So next. So there are various types of plastics. So main plastics, resin types of plastics are here listed here. PET. So PET bottles, high density polyethylene, milk bottles, ice cream containers, etc. PVC, the pipes, PVC pipes, cables, pipe chlorines, LDP, low density polyethylene, single use polyethylene, polypropylene, so chairs, medicine bottles, etc. So CD cases and also others, foamed polystyrene, hot drink cups, etc. Many other types, nylon, etc. are categorized into different types of plastics. Next, sir. Next. Oh, sorry, previous. So here, the global average plastic generation, plastic per capita plastic generation. So US, it is 109. So in kgs, so Europe, China, and Brazil. So you can say in India, it is 11 kg per day per capita plastic consumption. So in the sense, utilized by the various individuals. So next. So here the plastic waste treatment and conversion. So recovered waste. So collected waste. It is like recovered waste. So waste treatment, sometimes it is not recovered, and incineration without any energy recovery or directly goes to the landfill. Then it will be another section is it will be recovered. It will be going to recycling and energy recovery. And further here under recycling, mechanical recycling, dissolution, chemical recycling, or we can say energy recovery, MSW incineration, RDF plants, etc. Recycled plastics or monomers we can recovery, or we can convert it as a fuel. Or burning means we can get only energy. Next. So here we have one pyrolysis reactor, plastic pyrolysis reactor. Here also 2 students carried out their research in converting this plastic, or one student was working on generating the oil from the waste used tires, so upgrading it and utilizing in the IC engine. So another student worked on polypropylene oil. So polypropylene means you might have observed like Nilkamal chairs, one of Nilkamal chairs. So after prolonged usage, some powder started falling from the these. So after end use, end of life. So after end of life of these polypropylene, that is polypropylene chairs, so it will be converted into powders. So it will be utilized in the reactor to produce the oil. So we can say like 10 tons, we can get around 4 to 5 tons of oil. So both the students used this reactor to study, carry out the research, and also one of them has filed the patent, and one patent we received in this direction, upgrading the tire oil to upgraded tire oil. So upgraded tire oil means, so it will reduce the aromatics and also other problem causing compounds and increase the calorific value. So in that way. So second is F2. We have already filed the patent and to get some first examination report is also going on. So that we are representing. Next, sir. So way forward. So rapid urbanization, industrialization, growth of this population growth. So amount of waste production is also increasing. So there are many challenges associated with the technology, and mainly the poor public involvement in the solid waste management, lack of responsibility as a citizen on waste management. So these are major issues. So therefore, there is a need to develop that community awareness programs, and what are the requirements to solve these programs. We need to educate the people, and solid waste also be sorted. So in our homes, so we, like as per the instructions of the local bodies, we have to segregate. We are facing the problem of segregation in our campus itself. So if you ask for segregated waste, will not get, will get collected waste. So strict implementation of this segregation is also required. Next, sir. So utilizing these technologies. So now we should move towards AML. So technologies. So it is like from traditional research to we should move towards AML technology. So we are also working on one AML based sustainable waste management at NITK Surathkal. So it is like a Warrior Hub, Art Hub has been created. So it is like funded by one of the alumni. So we donated around 1 crore for different projects. And so one of the project is this AML based waste management inside the campus, and various departments also involved. So computer department, IT department, and along with the chemistry and mechanical department. So next, sir. Here, these are the waste available: food waste, dry waste, plastic waste, how effectively can be utilized. So next, sir. So here, enriching the gas up to 93%. So 93%, how to increase the percentage of gas. So here AML will be utilized mainly for increasing the percentage of methane. So different combination of feedstocks. So how we can optimize those feedstocks so that we can get the good quantity of methane. So in that way. So next. So here we are planning for the lab scale and scale experiments and different combinations through the software-based support system. So how we can get the more methane, etc. Next, sir. So this is again the AML technologies for optimizing the hydrogen production. So hydrogen production. This is the same gasifier, which is one of our student research scholar work, rice husk and biomass sawdust, and also cashew shell, cashew husk can be utilized in this reactor. So how we can improve the percentage of CO and H2. Main focus is H2. So here H2 in the sense how to improve the percentage by using the different combination of the biomass. Next. So here the various types of plastics will be used. So again, the increase the quality of the oil. So here the leftmost in the here you can see in the photograph some oil bottles. So upgraded one, so with the clear oil, crystal clear. So in that way, different combination of the plastics and how we can improve the quality of the oil. Next, sir. So here, so with this, I'm concluding my talk. So here, what I tried to convey is whatever the available resources, available technologies. So how we can utilize for the research, how we can give the awareness for the students, researchers, community, and scientific community, and also community around the campus, students, etc. With related to generation of energy from the waste. Waste is considered as a resource. Waste is not waste. Waste is considered as a resource, and we can generate energy out of it. So this is what I wanted to convey. It is not a research presentation. It is rather than my experience at NITK. So how we can manage the waste. So in that way, I'd like to thank, as I think previous slides, I would like to thank the coordinators, Nitin Davas and Satish More, and also Madhu is here. Yes. So I'd like to thank all the coordinators and Department of Mechanical Engineering, Department of Information Technology, and thank our Nutan Maharashtra Institute of Engineering for giving us an opportunity to deliver this talk. So I'd like to thank administration of NITP. Thank you. Thank you, one and all.
Thank you, sir.
Thank you, sir, for your sharing your experience and the waste
Yes.
management in NITK. So I think that waste is a very important. That management, waste management, is an important for the nowadays, because day by day the waste is increases if the population is increases. So I think you covered all the waste type, that is from the municipal waste, then food waste, biomass waste, plastic waste, everything you covered in your presentation. So this will be helpful for our participants, those who want to work in this direction. So now it's a time to interact with the sir. We are having the great time to interact with the sir. So I request to all the participants, please unmute yourself and interact with the sir. Shivaji, I think he's raising the hand. Shivaji, sir, you are having any queries? Shivaji, sir, you are raising the hand. You want to interact with the sir? Or you can write into the chat box. So I will convey that with the sir. Sir, I am having one query, sir, or question.
Yes. Yes, sir.
What is exactly the plastic oil and what is the use of this plastic oil?
Sir, plastic oil, for example, this polypropylene. Here, polypropylene we are using. Polypropylene means Nilkamal chair is there, no, sir? Nilkamal chair, one example, or some other companies also there.
Yes.
So that is the polypropylene is utilized for manufacturing these chairs.
Yes.
So after usage, end of life, so it will be converted into powders. So
Yes.
that powder is utilized for producing the oil. So there are many reactors. So it is like 100 kg, 200 kg. These reactors, batch reactors are planted as an MSME. They are operating nearby area. This oil, it will be utilized in the furnace. So that will replace this furnace oil. So in Maharashtra as well as Andhra Pradesh, I think Telangana, there are many kind of these pyrolysis reactors. They produce the oil and utilize in furnaces to generate steam, furnace boiler to generate the steam. So instead of furnace oil, this plastic oil will be utilized.
Okay.
So it will be, they are finding that it will be cheaper. One. So plastic oil is, if it is upgraded, so it can be utilized in the engines. The idea is utilization in the engines, more applications. So here we were facing some problem. So one of the industry located in nearby area, it is 10 kilometers, it is Baikampadi, so the place name. So they are supplying the oil to these generators. So some here, like throughout night, some Ekshagana in the sense cultural play, Ekshagana is going on. So that time around 1 o'clock, their generator got stopped. They were using these kind of oils.
Okay.
So then they realized that there is a problem with this because stability issues and unwanted compounds from the plastic oil. It was depositing on the engine walls. So because of that, it is stopped. So then they came here for some solutions. So because of that, research was started. So upgradation. So now upgradation oil we are giving to them.
Yes.
So in that way, solving the community problem. So if there is, and this oil can be utilized in the engine. That is there. So cost will be around 60 rupees plus GST will be there. So lesser than whatever the petrol. Other fuels.
Yes, sir. Yes, sir. Really, your work is really great, sir. It will be helpful for the society to manage the waste.
Yes, sir.
Yes, sir.
So here also, like nowadays, we need to change, sir, accordingly. We cannot depend on traditional technologies. So we
Yes.
need to bring in this AML. That effort is going on because now research scholars also focusing in that direction. So
Yes.
how to optimize, how to increase the percentage,
Mhm.
how to improve the quality of the oil or quality of the gas generated. So in that way.
Yes, sir. Yes.
Sir.
Birala sir, you want to share?
Yeah, just I would like to thank Dr. Vasudev sir. So even he is having the busy schedule. In spite, he agreed for our invitation, and today he made himself as available to us. Sir, once again, thank you for being with us, sir. So it will be really a good thing for us. And also, I request all the participants, because regarding this paralysis and the waste management, sir and team, they are really working good. So if you want any help, you can definitely reach out to this. So he will help you in all the ways. Sir,
Yes, sir.
once again, thank you, sir.
Yeah, participants, those who are willing for going for PhD or want to pursue MTech, so they can always approach. And also, so here, self-financed MTech program is also there. So they have to clear one test, so they can come for MTech master's program. And another one is self-financed PhD is also there. Or if you clear the gate, so you can always apply. There is also a test, so they can clear that and they can come for PhD also, pursuing PhD. So now, initially, some trend was decreasing trend. Now it is increasing PhD numbers.
Yes,
This
sir.
time, mechanical department has awarded around maximum around 30 PhDs from our department alone. Overall, around 193 PhDs awarded throughout the institute this time convocation. So I think Madhu was here and his batch. I think many of the students have passed out here. So
Yes.
not only in this area, any other area also they can approach. Not only limited to this area. Any area if people are interested, they can join us. Thank you.
Yes, sir. Thank you.
Thank
On
you, sir.
behalf
Thank
of,
you, sir.
on behalf of organizing committee, once again, thank you.
Thank you, sir.
Thank you, sir. Have a nice day.